Hello, Mr. Elvin, Mr. Ryan, alright? It's Sunday again.
Yeah.
Yeah, good, okay. So it's an easy question again, okay? So we're given a string of letters, only two possibilities, E and L.
Wait. Let me guess.
Okay, what's
Is
E?
it the longest? Wait, don't tell me. Is it longest subway or whatever?
No, it's actually easier than what do you think, okay? Please.
No, like subway, like the continuous like block.
No.
Like, this one has three like things and
I see, and this one has two. Okay, that's an interesting question, but it's a lot easier than that. Okay, so E stands for enter.
L stands for
Leave. Okay, so we have
enter, leave, enter.
That's right. So we are given this string of the two possibilities, E and L.
Is it like can't you just have the number 0? And if you enter, you +1, and if you leave, you -1.
Wow, bear in mind. Okay, I haven't talked about the question yet. Okay, I haven't talked about the question yet.
We've done questions like this before, and we just +1 with +1 and subtract 1. Oh, we do.
Really? Did I talk about this before?
Yeah. +1. Yeah. +1.
Okay.
Yeah.
So-
No. You didn't talk about exactly the same question.
yeah, I know it's similar. Yeah, you know what's
You talked about a solution like. You just like but then this has to be 1 instead of because I want 1.
No.
Remember you got +1 -1. Right. Remember we had this question where we had like a little brackets like.
That's right, bracket, the match bracket.
and you said like +1 +1 -1
No. If you enter then leave then 0, enter then leave then 0, enter then leave is 1.
Okay, can I say the question?
Yeah, you did the
please?
bracket.
Okay.
I think that's what we got.
But I'm very happy that you remember that. And the solution is actually quite similar. Okay, so let me finish the question. Okay, so the question is that we're given a string of E and L's. E meaning that enter, leave meaning L meaning leave. Okay, so we are simulating the person, the person entering the room and leave the room. Okay, so imagine there's a room, right? Now, okay, the people, the person. E means that one person, two person enter. Two people and three people. Okay, so initially, right? Initially, there are no people in the room, and then there are a certain number of chairs, right? For the people to sit. Okay, the chairs. Okay, so
That's a chair.
okay, never mind.
Stool.
That's the word Leo.
Okay. So the question is that what's the minimum number of chairs in order for all the persons, all the people in the room to be seated? So look, this one is 3, and this one is 2, right? Because look, if there are 2 chairs, right? If there are 2 chairs,
Wait, what?
Enter.
You enter then leave.
See?
1 chair, 1 chair.
Okay.
Wait.
Okay. So
Let
what?
me ask the question. What if it starts with L?
Very good. Okay, I haven't talked about it. That's very good. I need you to think. Yes. Okay. So
I
all the cases are valid. So there's no such case as you don't. There's no people in the room and you leave. Okay. So valid. It has to be valid. But very good. I'm very happy you.
But if
think
an
about
enter
that.
comes in
All valid
But if
cases.
an enter comes in front of a leave, then
That's right.
+1, and then if an enter comes in front of an enter +1, no. If
All valid cases.
No, if an enter comes in front of a leave, then leave it alone. But if an enter comes in front of an enter, then you add 1.
Okay, so all the valid cases. But another question which it could be quite challenging to solve is that how many permutations that give the valid solutions? It's just like
Doing what Ryan said.
Yeah.
Like if a result is negative, would it be 0?
There's no negative case, so there's no such case as ELL. Okay, so all valid. So you can drop, you can ignore the cases which are invalid.
What if it's just L?
Yeah, that's the same because it's invalid because there's no people in the
So
room.
do you just return 1?
There's no minus, there's no
So what do
negative.
you return?
So we want to
0.
return the minimum number of chairs here. So for example, like this one, right? EL, right? That's fine. And then EEL, right? So the maximum number of chairs In other words, it's the maximum number of people in the room is 2. So we return 2. So how do we solve this problem? Are we clear? For example, like let me give you another example. Okay, so then tell me what's the answer. Okay, E L L E E. So what's the answer?
3.
Oh, is this 3? Okay, so let's simulate the process. Okay.
3.
So 3 chairs. Okay, let's put the 3 chairs here. Okay, E L L E.
Wait, can
E.
you
Yeah, we're done. Yes.
Wait. Can you just do like, okay, just L and E next to each other plus 1, goodbye.
Goodbye.
And if it L and E then goodbye, plus 2.
Okay.
Something like that, I'm not sure about that.
But yeah, that's exactly. No, this is basically the same thing as a bracket thing.
Bracket thing. Okay.
Yeah.
So how do we solve this problem? I mean, if we iterate, we simulate, we basically implementation, we simulate from left to the right. So what are we tracking? What do we need to know?
Tracking the amount of people in there.
N.
The amount of people in there.
And then we just keep
then
tracking
we-
of the
and-
maximum,
yeah.
right? Yeah, that's it, right?
And if
Yeah.
we're tracking the amount, like we get, can't you just get a person, count the amount of people, and then count the amount of chairs, and then continuously subtract the chairs from the chairs from the people, and if it, but not actually do, but then if it ends up as negative, then you plus 1.
There's no negative, that's what I'm saying.
Yeah.
Okay.
I'm saying, okay, like there's
Wait,
one.
just so you know, we didn't hit anything apart from negative.
Let's say there's 3 people and 2 chairs, and then you subtract that equals 1. If there's another person comes in, that's 3 chairs minus 1, which is 0. But if there's if this is 4, then this will have to be minus 1. So you have to add 1 to this, which is then 0.
No, but we don't add 1 even if it's negative.
No, I'm not talking about that. You're not getting it.
And then
Okay, so how do we solve this? Remember the
I don't really-
example.
no, but
Okay.
since you said that the maximum number, if it was like EEL, would it be 2?
EEL, that would be 2, yes. Yeah. And then we don't care about how many people in the room after. We don't care about that, right?
Oh, okay.
So, how do we solve this? Just easy, right?
If the amount of chairs is bigger than the amount
Oh, no,
of people, if the amount of chairs is bigger than the amount of people, then add 1.
So you do what Ryan did, but with this thing,
Yeah.
but you could have this like set or whatever, or like counter or whatever.
Yeah.
it's called. When you first one, you plus 1, and then you change it to 1. And then second one, subtract 1, you don't change it. Add 1, then change it. Subtract 1, then change it.
Yeah, okay.
Add 1, then change it. Add 1, and then you change it to 2.
Okay, so we just keep tracking of the current the number of the people in the room, and then we record that we just track the maximum, right? So let me write the code, okay? So it should be very simple, okay? So define, Ryan, can you give the name of the function?
Define
Whatever, right?
Define
Max chair, right?
chairs.
Okay, max chair, okay, whatever.
What?
Okay, so S. Okay, are you right? Yeah, check it. Okay. So
From the
current equals
From
0.
the chocolate world.
The answer equals 0 for I in S. If
This
I
expires next
equal.
year. This
Yeah,
is
yeah.
expired next year.
If it's enter, then the current number of the rooms should be plus equal 1, right? And the answer should be the maximum of that, right? Everyone, am I right? Else, what else? If I equals L, so what should we do? The current should be minus equal 1, right?
And also, when you were teaching us like at day 1, I think I should have talked about like how you have to have those 4 spaces in front.
That's right, 4
Yeah, you
spaces
should
in
have
there.
told us about that.
You know, this is basic.
No,
It's not basic.
none of us knew.
Okay, but you know that, right? Okay. Okay, so let me Repeat. Okay, so current. What's current? Current is the number of the rooms in the number of people in the rooms, right, Ryan? Answer is the answer, right? Easy. It's the maximum number of the people, the chairs. We go through, we iterate the S. If it's E, it means one more person enters the room, then current plus equal 1. Then at this time we need to check what we need to check if it's the maximum, right? If there are 3, if current number is current maximum is 2, and then now we have the one more person come in, then we need to update it to 3. We basically checking the maximum. If I equals air, right? If it's not E, then it's air. If I equals air, so we minus equals 1. So this is the number of the people in the room, okay? And return answer. What's the time complexity?
O1.
What's the space complexity?
O1.
What's the space? Where's the space? This is one variable only. So
O1.
O1, yes.
O1!
Where's
No,
that?
I thought you had that tracker though. I thought you had that thing which changes that variable which.
Let's check the variable. You know what's ON? What does ON mean? What?
Look.
Look here, S, the number of characters in the string S, right? Why is ON for the time? Because we need to iterate from left to the right. Okay? Ryan, please. Yeah, we need to iterate from left to the right. But the space, look, we're only using a few variables. It's constant. It's a constant. It's not like we need to define an array with the inside. So this is O1, okay?
Okay.
Yeah, does make sense. But actually, look at this one. Ryan, you mentioned a good point, right? And then you as well. The E, plus 1, minus 1, S minus 1, plus 1, minus 1, plus 1, minus 1. Okay, so this is we can transform these to that, right? So we just need to calculate the previous sum, accumulate, right? Look, this is 1. So look at this. So let me get this, okay? Look at this one. 1 minus 1, 1 minus 1, 1, 1 minus 1, okay? So remember, this is the original array, and then we want to convert it to 1, 0, 1, 0, 1, 2, 1. Okay, so what's this?
2.
What's this?
Wait. You talked about it earlier, like
what's that?
Like. Wait, no, don't tell me. Wait.
This is original array. What's this? How do we transform? What is this called? This is the original
I
array.
forgot what it's called, but you talked about it before.
Prefix sum, right?
Oh,
Prefix sum accumulated, right? Yeah. So once we have this accumulated, we just need to find which number.
Sort it.
No. Which number is the answer here?
2.
So 2 is the largest. Yes, we just want to find the maximum. Okay, so we can do this using one single line, which is Ryan. Look, we use the accumulate, right? So we want to do this max accumulate. What's accumulate in English? What's accumulate in English?
I don't know.
Accumulate. You don't know the word.
No, yeah, means accumulate. That's what it is in English.
Accumulated. Okay, accumulate means these things add up together. Okay, accumulate 1.
How's one?
Yeah, 1. What's 1? If I equal E,
Chesley.
S minus 1 for I in
What?
S. Okay, that's it. Accumulate, right? Accumulate what? 1 if I equals E. S minus 1 for I in S, right? That's just one single line, right? And then this is accumulate. Accumulate. This is an iterator. We want to find the maximum, the same complexity. Okay, so
You do it.
the same complexity, but the space complexity is ON. Why? Because look, it has this space, right? Right, everyone. Look, this is ON space because we need to have a space to store the accumulated answer. Okay, so to store the prefix sum, so that's ON space. Do you get me now? But this one, we're only using the constant, a few numbers. This is O1 constant space. But both solutions, we need to iterate from left to the right. That takes n step. Okay? Yeah? That's it for today. Bye-bye. Bye-bye.